We want to say what x equals in order to make this be a true statement. But to say what x is supposed to equal, we have to get it out of the denominator. It's in the bottom of both these fractions, so that's no good. So we're going to multiply everything, and this is crazy, hang with me. We're going to multiply everything by x times x minus 1. That's because I have an x in the denominator here, so I got to multiply everything by x to get it out of the denominator. But I also have an x minus 1, which is a different term. So I also have to multiply everything by x minus 1. Okay, and so when I do that to this term, the x minus 1 and the x minus 1 are going to cross cancel with one another. And I just am left with 3x, right? And then when I multiply this stuff to this term, the x's cross cancel. So I'm left with 2 times parentheses x minus 1. So I'm going to write plus 2 parentheses x minus 1. And then there's nothing to cross cancel here, so I just kind of have an ugly term here. But at least x is out of the denominator. Now there's a possibility we can solve. I can distribute that 2. Distribute that 8x to everything inside here, so that's 8x squared minus 8x. It's quadratic because that's the highest power. So we solve quadratics by setting them equal to 0. So I got 3x plus 2x makes 5x over here. We can at least simplify that. And I'm trying to set it equal to 0, so I like to keep my x squared term positive. That just makes life easier down the road when we try to factor or something. So I'll subtract 5x from both sides. So I'm left with that negative 2 because it still had a minus sign to the left of it. And then we can add that 2 to both sides. So you're going to get 0 equals 8x squared minus 13x plus 2. You could factor it, try to solve this by factoring, or solve using the quadratic formula. Let's see if we can factor. I'm going to multiply the first and the last number. And my goal is to find two numbers that multiply to be 16, but add up to be negative 13. And well, what could we do? 8 times 2 would make 16, and if they're both negative, that also makes 16, but that happens to be negative 10. I don't think it's going to work. Yeah, there's no pair, so I think we have to use the quadratic formula. I just took this question from the book. Let me see. I think it's going to require the quadratic formula. I'm just going to double check. Of course, the book doesn't have it anywhere near. It's got answers for everything else, not this one. So I was going to check because sometimes I make mistakes and then I have to restart the whole video, but let's just go for it. Let's assume I haven't made any mistakes. I can't factor it, so I'm left with a quadratic formula. I have to use that. So it's negative, here I'll write down the quadratic formula. Okay, so negative b, so that's negative 13. Plus or minus the square root of 13 squared, which is negative 13 squared, that's 169, minus 4 times a times c, all over 2a. And if you're not sure what this is, just make sure you Google search the quadratic formula and see some problems demonstrated there. But this is your a, this is your b, this is your c. Okay, and so I can simplify this. 169, I got 4 times 8 times 2, so that's 64. 169 subtracted by 64, that's 105. So that's why we couldn't factor, because the discriminant doesn't come out to be an integer when you simplify the square root. So if you could take out, if you could divide 25 out of this number, or 36, or 49, that would help simplify, but I don't think you can with any of those, right? So I think that's as simplified as it can go. Or if you want the decimal equivalent, I shouldn't say equivalent, the decimal approximation, we'd take 105, we'd square root it, then you'd add this result to 13, then you divide by the denominator, which is 16. So one decimal approximation is 1.45. Then you do it again just with subtraction instead of addition. So I'm going to figure out what the square root of 105 is again. And then we do 13 subtracted by that number, then divide by 16, so that's 0.17. Those are our two decimal approximations.